All right, so from worksheet number 2, this is number 25. And what I notice is I have a binomial all over a secant. So I'm going to do, before I change everything to sine and cosine, which I am going to do, I'm going to multiply these two things by doing FOIL. So I'm going to take tangent times secant, which will be tangent x secant x. Then I'm going to take tangent times negative cosine, which is going to be negative tangent x cosine x. Then I'm going to take cotangent times secant, which would be a positive cotangent x secant x. And last, I'm going to take cotangent times negative cosine, which would be a negative cotangent x cosine x. And I have this whole thing over secant x. Now what I'm going to do is see if I got any like terms, which I do not, so I can't combine any of those. So my next step is I'm going to change everything to sine and cosine. So when I look at this thing right here, this is sine x, tangent is sine x over cosine x, and secant is 1 over cosine x. Now I got minus this tangent is sine x over cosine x. And then I have that times cosine x. I'm going to make that a fraction by putting it over 1, this cosine right there. Going to keep doing the same thing. So I got plus cosine x over sine x when you change cotangent from the quotient rule. And then secant is going to be 1 over cosine x. And then minus cosine x over sine x, which is the quotient rule again. A second here, let me fix that. And then that is going to be times cosine x, that cosine x. I'm going to put that over 1. And then in the bottom here, I'm going to change this secant to 1 over cosine x. Now, what I'm going to do up here on the top is I'm going to try to simplify as much of this stuff as I can on the top. So one of the things I notice is right here, I've got a cosine on the top and a cosine on the bottom. So I'm going to reduce these two to 1s. These will both go to 1s. If I look right here, this cosine and this cosine, they'll both reduce to 1s. And that looks like that's all I can reduce. So I'm going to rewrite my simplified pattern here. So I'm going to take sine times 1, which is sine x, and cosine times cosine is cosine squared x. And right here, I'm only left with a minus sign, because those are 1, sine times 1 sine, and 1 times 1 is 1. Right here, I've got plus, and I have 1 over sine x. And then over here, I'm going to have minus cosine squared x over sine x. And then down here on the bottom, I've got 1 over cosine x. So that's as far as I've got to simplify it so far. So what I'm going to do now is, I could have done this to step before, but I'm going to do this step now. This is called a complex fraction. So I am going to also put sine over 1 here. And I'm going to get rid of the complex fraction by finding my LCD. So we did this in class and I put it on several videos. I'm going to look at my bottoms and see if I have anything in common. So if you look, I've got a sine x here and a sine x here. So sine x is part of it. If you look, this thing right here is cosine x times cosine x, just so we know. So I've got a cosine x here, and I have a cosine x here, so that's another part of it. And then I have a 1 and another cosine, so it's another cosine times 1, which doesn't change anything. So my LCD is going to be sine x times cosine squared x. Okay, so I'm going to take this LCD, and I'm going to multiply it by every single term up here. So I'm going to take this times cosine squared x times sine x times the first one. I'm going to take that times cosine squared x times sine x on the second one. And by the way, these are over 1. I'm going to take this one times cosine squared x times sine x. That's this third one over 1, this part. And I'm going to take this one times cosine squared x sine x. over 1 times this one, and then the same thing in the bottom, cosine squared x times sine x all over 1. So I'm taking the top and bottom times this LCD. So now I can reduce more. So if I look over here, I've got cosine squared and cosine squared. So you can either mark those two out or this one, but those cosine squareds totally reduce to 1. So I'm left with sine times sine, which is sine squared x. Coming right here, nothing reduces, so this middle one is minus cosine squared x sine squared x, this part, because when I take that sine times that sine, that's sine squared. Here, this sine will reduce out with that sine, so I'm left with plus cosine squared x. And then this last one, that sine and that sine will reduce, so this is going to be minus cosine to the 4th x. So that squared times that squared is 4. And then down on the bottom part here, this cosine will reduce with one of these, and I will have cosine x sine x on the bottom. Okay, so now what I'm going to do is look for more like terms. Well, I don't really see any like terms, but I do see something that is an identity that I recognize, and that is I have a sine squared x there and a cosine squared x there. So I can flip-flop these two around right here. Okay, I can flip-flop these two around, so I'm going to have sine squared x plus cosine squared x, and I hope you remember that that's 1. So I'm going to stick a 1 in place of those two highlighted parts, and then everything else is going to stay the same. Okay, so now what I see is, what I think I want to do now is, I think I want to change this thing, because this sine square, do you notice we only have cosines and 1 on top, but we got this weirdo sine squared x? That's not sine and cosine. And from our Pythagorean identities, sine squared x is equal to 1 minus cosine squared x. So I'm going to change that into this thing, because that way I'll have all cosines in here. So I'm going to see what that does. So I got 1 minus that cosine squared x right there, stays the same, but in place of this, I'm going to stick this thing. So this is a real hard problem, by the way. And then I got minus cosine to the 4th x all over my common denominator. Okay, then I'm going to distribute negative cosine squared to both of these. So this will be 1 minus cosine squared x plus cosine to the 4th x. Oh, that helps right there. That helped a lot. That plus, this plus deal helped right here, because these two are going to cancel. When I took that negative cosine squared times that negative cosine squared, it gave me that positive one. So that was a good move. So I hope you see these two things are alike. So this positive cosine to the 4th cancels out with that negative cosine to the 4th. So now I have 1 minus cosine squared x all over cosine x sine x. Now what I'm going to do is I'm going to use this same identity right here, except I'm going to go backwards. You notice I got 1 minus cosine squared x on the top? So in place of 1 minus cosine squared x, I can stick that sine squared x in. So if I stick that sine squared x into the top, I can now reduce that one of the sine squared x with the sine on the bottom. I can reduce this one with one of these. So that leaves sine over cosine, which is tangent x, which is where we want it to go. So that is a crazy hard problem.